All right, guys, so we are going to begin the SPSS portion of week 13. Okay, go ahead and open up your data set and then your syntax file and notate here that is week 13, simple linear regression and multiple regression. All right. Now I want to preface this by saying that I will be using variables that we have coded in class already, okay? If you try running this syntax and you're getting an error saying, oh, you know, that variable doesn't exist, you might want to look back in your notes and find the proper syntax to recode these variables, okay? This is especially true for any variables that we recoded into dummies, some of the categorical measures like marital status and race. You need to make sure that you have created proper dummy variables for each of these categorical type measures, okay? All right, so let's begin first with simple regression. Okay, so again, remember that simple regression is just looking at one outcome variable that is continuous in nature, being influenced by one independent variable, okay? Now, when we run a simple regression, we can use different types of independent variables. So here is an example of running a simple regression with a continuous predictor variable, okay? So here's the syntax. Okay, regression, missing, we want it to produce list-wise isolation of missing cases. We want SPSS to report the coefficients and the R statistic. Now this line here, dependent, this is where you put your outcome variable. And again, anytime you are using linear regression, your outcome variable has to be continuous in nature. Okay, so ranging from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay, where each of the intervals means something, okay? So you put your dependent variable here. In this case, I'm going to use the attend variable, which asks respondents about their frequency of religious attendance or something to that nature, okay? The next line, method equals enter, you put your one predictor variable. In this case, I'm going to use education, okay? Education is the continuous predictor variable. So if we were to look at this model, what exactly are we assessing? Well, we are assessing the effects of education on religious attendance. So how does a person's level of education impact their level of religious attendance? Okay. Let's go ahead and run the syntax. Okay. All right. You are going to get output that looks like this. Okay. The first just tells you what variables you've entered. Okay, in this case, we're looking at the effect of education on attendance. Okay. The next window, you will see the model summary. Now, what we want to look at in the model summary is the R-square value. The R-square value tells us how much the independent variable has predicted the change or explains the change in the outcome variable. Now, typically for R-square, a larger value is better because a larger value means that the predictor variable explains a whole lot of the changes that we see in the outcome variable. Okay, this becomes especially important when we are using multiple independent variables. So right now the R-square is really, really small. That's because we only have one predictor variable, right, influencing the outcome variable. So the amount of explained changes is very minimal because only one variable can explain changes very minimally in the outcome. All right. The last box is the coefficients box. Now this is your regression results, okay? Don't worry about this constant line. We will not be interpreting this in this class, okay? But here you can see the variable, your independent variable, okay? Now what we first want to look at is this coefficient here. This is called the B coefficient. The B coefficient is 0.037, okay? What we can deduce from this coefficient is that it's positive, okay? So that means that changes in education are associated with increases in religious attendance because it's positive, right? Now, the way you formally interpret a regression coefficient is as so, okay? For each unit increase in education, right? So as education goes up 1 unit, right? For each unit increase in education, there is an associated 0.037 unit increase because it's positive, in religious attendance. Basically saying, as education goes up, religious attendance goes up. And it goes up at this unit. So it's a small unit, 0.037, okay? Now, how do we know if that relationship and this effect is statistically significant? We go straight to this sig column, okay? And we look at this sig value here, this p-value. If you remember from last week, this would be statistically significant at the 0.10 level because it's less than 0.10, all right? This is the level of significance that gets that little cross value, all right? So again, let's look at this. This is how you would interpret this result. For each unit increase in education, there is an associated 0.037 unit increase in religious attendance. And this relationship, this effect, is statistically significant at the 0.10 level, period. That's it, all right? Very simple. Let's go ahead and try another one. Let's look at how number of children influences religious attendance. So we're going to use the same code, except we're going to, instead of putting education, we'll put child's, which is the variable for number of children. Let's go ahead and run this. Okay, we get the same output here. It's telling us that we've included number of children to predict religious attendance. If we go down here to look at the R square, we have 0.026. Let's go up to the R square for education. Okay, so education, the R square was 0.002. The R square for number of children is 0.026. So this R square is larger. So what this means, remember, a larger R square is good. What this means is that number of children explains more of the changes that we see in religious attendance than education does. So child's number of children is a better predictor of religious attendance than education is, okay? That's what that means. Now let's go down to the coefficient box. Again, you're going to ignore this constant. We go straight to the variable here, all right? It's a positive coefficient, and it's statistically significant, very significant. So how do we interpret this? We say, for each unit increase in the number of children, there is an associated 0.271 unit increase in religious attendance, and that is statistically significant at the 0.001 level. So what does this result mean? It means that the more children you have, the higher your religious attendance is, okay? So as number of children goes up, religious attendance goes up. Okay, and this relationship or this result is not occurring by chance. It is statistically significant by looking at this sig column here. Okay. All right. Now we are going to move on to using simple regression with categorical measures. Okay, so the previous ones we were using continuous predictors, right? Now we're going to use categorical predictors. Okay, the first example I'm going to use is just a simple binary categorical measure of sex. So early on in class, we recoded sex into a dummy variable. Okay, remember, anytime you insert categorical measures, you need to first make them into dummies so that they're coded 0, 1. All right, so this dummy is comparing men to women. Okay, so we're looking at how religious attendance is influenced by sex. Okay, so let's go ahead and run this model. Again, R square, it's a pretty low R square. That just means that gender or sex does not explain very much of the changes that we see in religious attendance. Let's go down to the coefficient box here. Now, pay attention here, because the interpretation for dummies is very different than when we are interpreting coefficients of continuous measures. The way you interpret dummies is as follows. When compared to women, right? When compared to women, men have a decrease in their religious attendance. So it's a decrease because it's a negative sign, right? When compared to women, men have a 0.549 unit decrease in their overall religious attendance, and that is statistically significant at the 0.001 level. So it's a very significant result. So what this is saying is that men typically are less involved, or they attend religious services less than their female counterparts. Okay. All right. Now let's predict religious attendance using the categorical measure of denomination. And if you remember, we created these dummies from the denomination categories. So here, the 4 categories that we had created for denomination was Protestant, Catholic, no religion, and then other religion. We created dummies for these 4, okay? Now remember, you always want to leave out the largest category. If we were to run frequencies of these, we would see that Protestant is the largest group. So we are going to leave them out from the regression model, okay? So attend, we're going to put in Catholic, religious nuns, and religious others. And make sure that when you are putting these variables in, that you are spelling them the way that you spelled them when creating the dummies, okay? All right, let's go ahead and run this regression. You can see the R square here, meaning that religious denomination or your religious affiliation explains a lot of the changes that we see in religious attendance. And that makes sense, because depending on your religious affiliation, you either attend church a lot or not very much. Typically, Protestants have higher levels of religious attendance, followed by Catholics and other groups, okay? So this R square is saying that denomination explains a lot of the changes that we see happening in religious attendance. Going down to the coefficients. All right, I don't know where my coefficients went. Let me rerun this really quick. Okay, there it is. All right, so the way we would interpret this is as follows. Remember, we left out the Protestant group. So every category here is being compared to Protestants, okay? Okay, we can see first that they're all negative and they are all significant. So the way we would interpret this is as follows. When compared to Protestants, Catholics have a 0.70 unit decrease in their level of religious attendance, and that relationship is statistically significant at the 0.001 level. So what this is saying basically is that Catholics attend church less regularly than Protestants do, and that's expected. Well-known and religious other. Let's go ahead and interpret other religions. So when compared to Protestants, people of other religions have a 1.36 unit decrease in their religious attendance, and that relationship is statistically significant at the 0.001 level. Okay? All right. Very good. That is going to sum up the SPSS portion of simple regression. The next SPSS video that I will be posting will be the SPSS portion of multiple regression, which is a bit more intricate and complex. So make sure you have a good understanding of simple linear regression, and then go ahead and proceed to the multiple linear regression video. Bye, guys.